Hi, welcome back. Having covered Newton's laws, linear and rotational motion, forces, torque, linear and angular momentum, it is time to check for the conditions for static equilibrium. We already know that in the absence of external forces, an object will be at rest or in uniform motion. The object will experience no acceleration. In other words, the object will remain with constant linear momentum. The object will be in translational equilibrium. In the absence of external torques, the object will move with constant angular momentum. So if the object was initially spinning, it will continue to do so with constant angular velocity. The object will be in rotational equilibrium. If the sum of the external forces is zero and the sum of the external torques is zero, the object will be in equilibrium. If the object is at rest and not rotating, we say that the object is in static equilibrium. So if we see an object in static equilibrium, we know that those two conditions are satisfied. That is, the net force is zero and the net torque is zero. This gives us tools to explore and study extended objects on the complex combinations of forces and torques. Remember that the torque is referred to as a specific point, but in equilibrium, no matter the point, the net torque will always be zero. Let's have a look at an example. Consider a homogeneous bar of 200 newtons of weight and a length L. The bar is resting on two flat surfaces that make an angle of 60 degrees. The bar makes a 40-degree angle with the horizontal surface. We apply a horizontal force F at one end of the bar so that it is in static equilibrium. Let's determine the magnitude of the force F and the reaction at the point of contact between the bar and the surfaces. First thing we have to do is to draw the free body diagram, being careful with the point where forces are applied. Here we have the weight or force of gravity, this one applied at the center of mass of the bar. We also have the external force F. Then we have 2 points of contact, so we have 2 normal forces, one at point A, another at point B. So we have these 4 forces. Because the bar is in static equilibrium, the sum of all the forces is equal to 0. But also the sum of the torques is equal to 0. We need to choose a point with respect to which calculate these torques. Sometimes it is useful to do it with respect to the point where there are several forces applied. That way they will not appear in the equation. I will choose with respect to point A. Now I will decompose the forces into X and Y. F, N1 and weight are simple. For N2, I need to pay attention to find the angle with respect to the horizontal. If this angle is 60, then this other is also 60. Therefore, this one is 30. So Newton's second law and the equation of the torque. Now it is only a matter of solving this system of equations. We have 3 equations and 3 unknowns. Let's put some background music and see how this is solved.